Hey guys, welcome to 4.3. Let me see if I can make this a little bit more clear. Awesome. All right, 4.3 compound exponential equations. So here's our warm up for today, and the warm up is what we learned in 4.2. The price of gas is currently $1.85. Ooh, I forgot a dollar sign. And it is steadily decreasing 2% per month. I wish. It's going up, isn't it? How many months will it take to get the price down to $1.75? So the formula that you used in 4.2 was y equal, okay, your a, 1 plus or minus r raised to the x. This right here is a very exponential equation. So let's take a look. The price of gas is currently $1.85. So that is our beginning amount, $1.85, okay? 1, and it is decreasing, so it's going down at 2%. Now 2 over 100 is 0.02. So there's your rate, 0.02. How many months, there's your x, will it take to get the price down to $1.75? This is your ending amount. Okay? There are many ways you can do this problem. The easiest thing to do is you're solving for x. So you could go ahead and do what's inside first, or you can leave it like it is. What I would do, the easiest thing is, I want you guys just to estimate. Type this into your y equal. Okay? So type all this into your y equal. And my highlighter is not very good today. My apologies. I am at home. So you're going to type this into y equal. Now notice this is your y. Just like so. Okay, so we're going to type all of that in. So you go to y equal, excuse me, let me clear that. Go ahead and type in your equation, 1.85 parentheses, 1 minus 0.02 raised to the x. And this is the x you use right here. Guys see that? All right. Now you can go to your table. Look for where the y is $1.75. So around right there. At 3 months, it's $1.74. So the question says, how many months will it take to get the price down to $1.75? Well, in 2 months, it'll be $1.77, so that's not $1.75. In 3 months, it'll be $1.74. So your answer is 3 months. Okay. For now, just use this to estimate. In the next unit, you will tell me exactly how to find it. But for right now, that's what we're going to use to try to figure out the solution. Just estimate. So around 3 months. All right. So today's assignment. Make sure you turn in your warm-up for 4.3. Here is our assignment for today. Compounded exponential functions. Students will be able to determine the growth or decay of compounded interest. So the formula you guys have used, this one right here, okay, this is just an exponential equation. It's for the basic interest equations. But today you guys are going to learn how to compound it. What does it mean? It just means that you have, say for example, it's compounded annually. So whatever interest you earn, you're going to use that. Say you get 10% interest, you have $100. So now you have $110. You're going to use $110 and get 10% more, and that will give you $11. And you're just going to keep adding on top of things. And that's what compounded means. It means I'm going to keep adding and adding and adding and never taking out the interest. Okay? That's what you really want to do when you are saving. Just thought I'd let you know. The formula for the compounded interest, notice what we add. This is something new, okay? The original formula that you learned was a 1 plus minus r raised to the x. That's what you learned in 4.2. That's the basic exponential equation. Now we are adding compound, so we're going to keep stacking things on. Now I want you guys to notice something, okay? These are the same. instead of Y, they use the letter A. See that right there? Equal, instead of A, the lowercase a, they use the letter P. Okay, which is basically mean your principal amount. 1 plus R, okay, plus or minus R really. And now notice the N. We're going to learn a little bit about the N. Okay, raised to the N times T. So instead of X, they use the letter T, but it all means the same thing. These are the same. So what does A mean? A means the amount you enter after a certain period of time, amount you have. Left off a word, didn't I? Amount you have after a certain period of time. Your P is your principal. It is the beginning amount. Your R is your annual interest rate between 0 and 1, which is between 0 and 100%. Remember, you need to convert this to a decimal. N is the number of times the interest compounds each year. This one is basically doing it once a year, okay? And T is the times in years. All right. So let's take a look at some definitions. How many times a year? Okay, does it? So I want you guys to write this down. So give me just a moment. All right. So annually, what does annually mean? Once a year. So your N is equal to 1. Okay? Oh, I've got this student started on a test, so give me just a moment. All right. Semi. Semi means 2. Sometimes you may see the word biannually. It means the same thing. So biannually, the N is 2. Okay? Quarterly. Quarterly, 4 quarters in $1, so 4 times a year. So make sure you guys have all that. Let me get a kid started on the test. Okay? Next is monthly. How many months is in a year? 12 months. These are your N's. These are your N's. Weekly. How many weeks is in a year? 52 weeks in a year. Okay? Daily. We're going to use 365, even though we know there's a quarter somewhere in there, a year. Okay? Alrighty? Hourly. Well, let's take a look. We have 365 days in a year. Okay? How many hours is in one day? 24 hours. So, you take that, 365 times 24, and what do you guys get? Alright? Using. Alright, she is ready to go. Okay, so let me get a calculator. So hourly is, you guys will be surprised how many hours is in a year. 365 times 24 hours in a day, so that's only 8,760 hours in a year. Shocking, huh? Okay, I'm going to keep doing my math. 1 hour has how many minutes? 60 minutes. So notice what I'm canceling out. So now I'm going to take that number and I'm going to times it by 60. So there's 525,600 minutes in a year, okay? And 1 minute has how many seconds? 60 seconds. So I'm going to times that by 60. So that's 3153600. So that is 31,536,000. All right. Half a second. Well, 1 second is equal to how many? Half is 2. So 2. So I'm going to multiply that times 2. 6307, 2 0 0 3 zeros. and that'll give you 63,072,000. Okay, so there's your N. Make sure you keep that handy because you're going to use it quite a bit. All right. Okay, now let's be a little bit more realistic today, and we're going to use that to help us. We've been performing basic exponential growth or decay, so let's look at another simple example for anything that we might overlook in the process. For example, a bacteria growth, okay? Give me just a moment. Okay, so here we go. I am so sorry about that. All right, a bacteria starting with 100 bacteria is doubling every hour. How many hours will it take until there are over 1 million? Okay, so let's kind of look at this example real quick. So how would you even write this up? Well, we start off with 100, so you can say that is your A, and sometimes some of you may use the capital letter P. All right, and that's the same thing. It's doubling. So R is 100%, which is the same as 1, every hour. How many hours will it take until there are over 1 million? Now, 1 million has 6 zeros, okay? Thank you, Rainey. I'm making a video. Continue with your test, girl.
Okay, thank you.
You're welcome. All right, so how would I write this up? So I would say Y equal, I start off with 100 bacteria, 1 plus R, which is 1, over your N, hours. How many hours is in a year? 8,760. Okay? Raised to the N, and it says how many hours. So I don't know what that is. I can put an X, or some of you will put a T. It doesn't matter, okay? And it says over 1 million. So my Y here is 1 million. And you can actually just solve all of that, but we'll do that in a little bit. I'm not going to worry about that, but that's how you would write this equation. So let me rewrite it to make it a little bit prettier. And you can do a T or an X, your choice. Okay, we'll come back to that in later on. But that's how you would write that equation. See how you're plugging it in? Because after every hour, you keep adding more and more and more. And that's how bacteria grows, and virus, and all that. All right, next part. Hopefully we'll touch on the underlying problem. Do things really only grow or decay at the end of a given time period? Of course not, but for our purpose, we are going to, this means that the math we're doing is reasonable, but not fully accurate, okay? So let's look at the banking industry. Banking, how nice. All right, so let's look at our first example. Now we're going to apply everything we learned. Remember, you can use this formula, 1 plus or minus R over N raised to the N times T, or you can use A equals P, 1 plus minus R over N raised to the N times T. These are exactly the same thing, right? All right, here we go. Suppose the bank tells you they will let you invest $5,000. I like to use this one, so I'm going to put P. Okay, so notice I use capital A, lowercase a, at 3% annually. So your N is 1. How much money would you have after 1 year and 10 years, respectively? All right. So we have A equals, I'm starting with $5,000. Do not put any units when you are doing your math. I am growing because I'm investing, plus 0.03 raised to the 1. Okay, so 1 times 1 year. There's one of my problems, so I'm going to put a 1 here. The other one is for 10 years. 5,000, 1 plus 0.03 over 1, n times 10. Did you guys see how we have those two problems? Okay, so let's type this one in first. Just like you see it, I'm going to clear that so you can see it better. 5,000, watch how I type, 1 plus 0.03 divided by 1. Notice I didn't do anything. I just typed it like I see it. Raised to the 1 times 1. That's for 1 year. So how much am I going to have in 1 year? $5,150. Okay? How about 10 years? Look what I do. I went back and grabbed it, and I changed this to a 10. Do you see what I just did? Okay? Let me clear it and try to show you again. I have the same equation, so I just went and grabbed it and pushed enter. Backspace, 1 times 10. So in 10 years, notice how I label. How much money am I going to make from $5,000? $6,719.58. Okay? And there you have your banking. Look how much it grows. At 3%, that's not bad, huh? You made $1,700. That's not bad at that rate. Scenario 2. A bank tells you they will let you invest $5,000 at 3% annually, but they will give you interest payments 2 times a year. So your N is 2. Semi-annually, biannually, in June and December. How much money will you have after 1 year, okay, and also 10 years? Well, let's do it for 1 year first. A equals 5,000. Okay.
Here's a result from search.
Oh, my calculator's being crazy. My phone. 1. I'm growing at 0.03% twice a year. See, my n's a 2. Raised to the 2 times 1. Because I'm going to do it for 1 year. So in 1 year, how much money am I going to make if they pay interest twice a year? Let me clear that. 5,000, 1 plus 0.03 divided by 2. Notice my n's a 2, raised to the 2 times 1. See how I did it all in one stroke. I will only make $1 more. 5151.13. How about for 10 years? Okay, same scenarios. 1 plus 0.03 divided by 2, raised to the 2. So in 10 years, how much am I going to have? Same thing. Watch what I do. Go back up, grab it, backspace over, and put 10 in that place. So $6,734.28. That's not bad. Just a little bit more if I earn interest twice a year. Okay. All right. Providing interest payments more than once a year is known as compounding, because we did it in June. Whatever we got in June, we add to it, and it just keeps growing and growing. That's why this is a better deal, and this is called compounding. Okay? Let's look at scenario 3. Same thing, except we're going to change a few things. A bank tells you they will let you invest $5,000 at 3% annually, but they will give you interest payment each day. Well, how many days is in a year? 365 days, and we are compounding. How much money will you have after 1 year and 10 years respectively? All right, so I'm going to write my generic, and then I'm going to change it in a little bit. So 5,000, 1 plus 0.03 over 365. N is 365 times your T. Notice how I just wrote my equation. You can do it like that so you don't have to write it. How much would it be for 1 year? Okay? So I'm going to plug in 1 right there. 5,000. 1 plus 0.03 divided by 365 raised to 365 times 1. $5,152.27. Round correctly, please. How much would it be for 10 years? I do the same thing. I'm going to go up and grab it. Instead of 1 year, I'm going to put in 10 years. $6,749.21. And there you have it. Okay? All right. Obviously, this kind of competing between banks could go on and on. We could compound interest every hour, minute, second, half a second, millisecond. You get the idea. But before we move on, there has to be a limit to this process. Okay? That limit is called continuously compound. That means it never stops. It happens all the time, even when you're asleep. The next lesson, we'll talk about compound interest. But for right now, this is all I want you guys to do. I did give you some kind of, if you want to read some articles about it, here's some articles, okay? But there's your assignment for 4.3. And here's the formula again, in case you forgot. 1 plus or minus 0. Not 0, r over n raised to the n times t. There's your formula. Alright guys, all I ask for you is you can write that one time and then you can just give me your answers like that. Okay, so you don't have to do it over and over. But give me the formula you would use and that would work. Thank you guys.